All right, so exponent loss. We're looking at what a negative exponent means. So in this chart here it gives an example where we've shown it in multiplication form. Okay, go get your bag. Go get it. So here is an example where we're dividing 8 cubed by 8 to the 7th. So the exponent on the divisor is bigger than the exponent on the original. So when we show this the long way, we have 8 3's up top, 3 8's up top, 7 8's in the denominator, and we divide out the common factors. Okay, so we divide out 3 8's. What we're left with is 4 of them. So that's the same as 1 over 8 to the 4. If we think about our rule for dividing powers with the same base, we subtract the exponents. Okay, so that's how we can show this as a power, but those have to be equal. So you can see this arrow here. Whenever you see a negative exponent, that means that there are 4 8's in the denominator of a fraction. Okay, so if I have here, this example here, if I have 5 to the negative 4, same exponent as that original one, that's 1 over 5 to the positive 4. So oftentimes, we want to show powers with positive exponents. If it's a negative, we need to make it positive. Okay, so the rule, a base raised to a negative exponent is equal to the reciprocal of the base raised to a positive exponent. So the reciprocal of 8 is 1 over 8. Reciprocal of 5 is 1 over 5. Now, technically, with this wording, we should really go 1 over 8 to the positive exponent 4. But remember, when we do that, 1 to the 4 is 1, and 8 to the 4 is 8 to the 4. So we kind of skip this step. This is what happens in words. This is what really happens. Okay, but we skip this step. If it was a fraction to start, then we would start a fraction. Okay. So our general rule here, if the base is a, then this is going to be 1 over a, the exponent n. And why do you think a can't be 0? And specifically in this type of power law. If a was 0, what would be in the denominator? What would you be dividing by? If a was 0, this would be a division. 1 divided by what? It would be 0. And what's wrong with that? You can't divide by 0. It's undefined. You can't figure out how many zeros there are in a number. Because 0 doesn't have a value. Okay? So that's the most common type. When your base is a variable or a whole number. If your base is in fraction form, then it will be, or likely you'll have brackets. It may have a negative exponent just on part of it, but for right now, we have a fraction and brackets around the whole thing. So that means that exponent applies to the whole thing. Then we flip the fraction to make the exponent positive. You take the reciprocal. Okay? Flipping is sort of the non-math word to use. You need a pencil? You can get one out? Okay, so this one here, 2/3, that becomes 3 over 2 to the positive 3. Okay? And then you can evaluate these. Okay, so that's changing it to positive. Then you can evaluate. So let's do that. 1 over 5 to the 4th. Remember we did 5 to the 4th yesterday. It was 625. Okay. This one, 3 halves to the exponent 3, that really means 3 cubed. So 3 times 3 is 9, times 3 is 27, over 2 cubed. 2 times 2 is 4, times 2 is 8. Now, if we were to get our calculator out, just give me a sec here. Okay, so if we get our calculator out and we evaluate this negative exponent, that would be 5 to the exponent negative 4. Enter on that, and you'll notice you get a decimal value. I'm not going to want decimals. Okay, so when we're asked to evaluate in high school math with negative exponents, we want the fraction form. No decimals. The odd time, you might say use a decimal if it was a numeric response, but mostly no. Okay, now, how can you check? Well, if I go 1 divided by 625, I got the same value. Okay, so you can check your answers, but you need to understand the concept of negative exponents in order to do that. Okay, now there is a math fact key in your calculator, which you can use to check as well. If you did something like this, you would have to be very careful to have brackets around the whole thing. So bracket, 2 divide 3, close the bracket to the exponent negative 3. And again, you get a decimal. If you have a newer version of a calculator, you could go bracket and do the fraction form, alpha y equals the first fraction, and then put 2 over 3. Cursor out, close the brackets to the exponent negative 3. Okay, that actually, it gets rid of the brackets, which I don't really like the calculator because of that. It does actually convert it to a fraction, which is annoying for teachers. But you're going to have not just numbers. You're going to have things with variables, so you have to understand the concepts. All right? Okay. So that is what a negative exponent means. All right? So let's take a look at this. It says if 3 to the negative 2 equals 1 over 3 squared, that's the law. And if we evaluate that, that's 1 over 9. Then what do we do if we have a negative exponent on a number that's in the base? So when it was in the numerator, we flipped it to the denominator. When it's in the denominator, we should flip it to the numerator. So anytime you want to change the sign of an exponent, then you're moving it from the numerator to the denominator. Andre, can you sit up, please? Okay, so here, this is going to end up being 3 to the 2 over 1, which is just 9. Okay, it says use a calculator to check. So we're going to go 1 divided by, and then here 3 to the exponent. We may need brackets. I'm just going to check. 3 to the exponent negative 2. It should refer directly to that 3, and it does. If you want to put brackets around the whole thing, you can. But here, to make it positive, we flipped it to the denominator. If it's in the denominator, to make it positive, we flip it to the numerator. One or the other. Okay? If you, not that we ever do it, but if you had a positive exponent and you flipped it to the denominator, it would become negative. Not that we really do that very often. We really want positive exponents in order to evaluate. Okay? All right, so express each power with a positive exponent and then evaluate. So I'm going to want two things here. You can't just punch it into your calculator and give me the answer. I want it expressed with a positive exponent. So this is 8, so the 8 goes in the denominator to make that a positive 2. And then you evaluate 8 squared and leave it in the denominator. Okay. You can check with your calculator, but I need to see those two things. If there's brackets in the original, then you just keep the brackets when you do the flipping, right? So it'll be 1 over negative 8 to the positive 2. Very similar to this one, but there are brackets around negative 8. So that goes to the denominator. And then you evaluate. Right? It says evaluate, which means you find the value. The word's right in there. Okay? So that's going to be 1 over negative 8 squared is going to be positive 64. So those have exactly the same value. Okay? Even though one's a positive base and one's a negative. So then 1 over 8 to the negative 2, that's like this one here. So the negative base is in the denominator. So now it has to go in the numerator. Okay. And we don't show the 1. Just evaluate. That's going to be 64. The 64 divided by 1 is the 64. And then D, be really careful. D, that negative 2, only refers to the 3, not to 3 over 2. There are no brackets there. So what happens here is, in your fraction, 3 squared is in the denominator. Okay? 2, there's nothing done to it. It's just a 2, and it's in the denominator. So that stays in the denominator. And if we move something down, remember it has to have a 1 up top, taking the reciprocal. So we're only moving this part down. And so then that's going to be 1 over, 3 squared is 9 times 2 is 18. Okay, so now we're getting into simplifying, which we've already reviewed those laws, but now we might have negative exponents. And if we do, once we simplify everything, if we get down to a power that has a negative exponent, then just show it as with a positive exponent. So flip it. Okay? So here, power of a power, you multiply the exponent. So who can tell me the exponent before I do any flipping? Hands up. Negative 18. Good. Now, got to make it positive exponent. As you go on in math, there'll be times where you need it as a negative exponent, but that's actually more past high school. Usually in high school, we want it as a positive exponent. Or you leave it as a negative if you're going to do some other work with it. And notice how it doesn't say evaluate. If you tried to do that, you probably, if you just did the 5 to the 18, it would be a really big number. If you get anything like this, notice how it's a decimal. Well, how can 5 to the 18 be a decimal? Well, it's a decimal because there's E12 at the end. That's called scientific notation. On paper, we go times 10 to the 12. So that means that would move the decimal 12 to the right. So it's a huge number. You calculate it, you can calculate it, but you can't show you all the digits. So it converts it to scientific notation. In any case, 1 divided by that would be, again, a decimal e to the negative 13, because it's a small decimal. The decimal is moved to the left. But we don't show it. Okay? I didn't ask you to do that. Next one, you're dividing powers of the same base, so keep the exponent the same. And then 20 divided by, 20 subtract 32 is negative 12. Remember, you're subtracting the exponent when you're dividing powers. Okay? So that's a single power. And then with a positive exponent, it's 1 over 9 to the 12. Okay. Now you'll get to the point maybe where you don't even need to show this. I asked you to, so you have to. But if you're doing work with powers, then you don't need to. Because think about what this looks like in your head. There's 20, think of 20 9s in your numerator, like this. And then we've got 32 in our denominator underneath. So you know you have way more in the denominator. How many more is 32 minus 20 is 12 in the denominator. So if you can imagine how many of that base you have in each part and where you have more, that's where you show them. Okay. Next one, order of operations. We've got to do the power of a power first. So that's 4 to the 6. And then you're multiplying powers with the same base. So you add the exponents. And then you show it with a positive exponent. You can tell me what the answer to that one is with a positive exponent. Yep, Ben? Good stuff. Okay. So it just goes into the denominator. Those all had numbers as their base. Now we'll have variables. Okay. So, same, we're multiplying here. So the base is A. 2 plus negative 5 is negative 3. Well, we got 4 to the negative 3 on the last one. Now all that's different is in A. So A is going to be in the denominator. To the positive 3. Okay. Then this one, kind of like the last one, C on the last row, we're raising a power to a power first. So we have to do this part first. So it's going to be y to the 12. And then that's going to be y to the negative 16. And you multiply those exponents together. And then you're multiplying powers with the same base. So you add the exponents. So you can tell me what that is before converting to a positive exponent. What do you get when you simplify that to 1 power? Good, y to the negative 4. Okay, and then, so to make that a positive exponent, it's going to be 1 over y to the positive 4. Okay. And then a few things to do in F here. So there's power of a power. And then, really, it's kind of like having brackets there at that whole numerator. So, I'm going to do that first. That's n to the 6 times n to the negative 14. Just copy everything else out the same. Okay? So, that just becomes that. Then, you can actually do this all at once, but I would do the numerator. It's like having brackets. Okay? So, finish off the numerator. That's going to be n to the negative 8 over n to the negative 3. Okay? And you might think, oh, well, I'm just going to take each one and make it have a positive exponent by doing the correct process, but finish it off first. Why bother doing it twice? Now, if I'm subtracting these, just be careful. It's integers. You're taking negative 8 and you're subtracting negative 3. That's like adding 3. So that's going to end up with to be negative 5, not negative 11. So just be careful on that. Then, make that positive. Alright, so then on the back page, I'm going to do some more with some fractions. So we can turn over. It says, write each of the following powers using positive exponents only, and then evaluate. And then evaluate, but no decimals. So don't convert fractions to decimals. Just evaluate them. So that one here, the first one, negative exponent, the brackets on everything. So that means we flip the fraction. math word is reciprocal, to make it a positive exponent. Okay. Then remember what we learned the other day, right? So you're squaring 5 and you're squaring 7 and keeping them in the correct place. So this is 5 squared over 7 squared, which is 25 over 49. Okay. If you want it, you can skip this step if you want and go right to here. Okay, but no decimals. Okay, same with the next fraction. Flip it, change the sign of the exponent, and then evaluate that. Okay, so 2 to the 4th over 3 to the 4th. And that's going to be 16 over 81. Now you can check your answers. Right, so bracket 2 divide 3, close bracket, exponent 4. And then I think the answer is 16 divided by 81. I get the exact same decimal. Right, so you can check. If I didn't, I'd go back and see. Did I forget to flip it? Did I only square the 2 or raise 2 to the exponent 4 and not 3? Something like that. Okay. So, question 5. Simplify and express with positive exponents. So now we're putting it all together. We might have numbers and variables inside the brackets. And we might have negatives that we have to make be positive. So, remember back from the other day, or I guess this was yesterday, we were doing stuff like this with the number and variables. So you're squaring everything. So 4 squared, x to the negative 6, y to the 8. So you square the number, and you square every variable in there. If it's raised to an exponent already, then you multiply the exponents by 2. Now, I suggest circling anything that has a negative exponent. Because sometimes students think, oh, I'm just going to move everything down to the denominator. But you can't. This is the only one with a negative exponent. So, what stays up top is 4 squared y to the 8. Well, what's 4 squared? That's 16. Y to the 8 stays. And now, x has a positive exponent in the denominator. Okay. So that's why I suggest circling whichever factor has a negative exponent. That's the only thing that moves. Okay, so same thing in the next one. Every factor gets raised to the exponent 3. Okay. So try that out. 3 cubed, m to the 15, m to the negative 15. And circle the factor that has a negative exponent. I'll do it in a different color. And that's the only thing that moves. Okay. 3 cubed stays, which is 27. N to the 15 stays. But n becomes n to the positive 15 in the denominator. So this, to make that positive, goes down below. Okay. So those were powers of powers. Well, yeah, some powers and some constants. And then here we're multiplying these monomials together. So we multiply the coefficients. We multiply anything with the same base, so anything with x in it. So when you're multiplying powers with the same base, you add the exponents. So that's going to end up being positive 3. So I always suggest simplifying before you deal with any negative exponents, because maybe they'll end up being positive, like in this one. And then y to the 5th times y to the negative 9, add those together, that's y to the negative 4. So even though we had 2 factors that had negative exponents in the original, we really only have one. I'm going to circle that one, because that's the only thing that needs to move. So 15x cubed stays, and then y to the 4th in the denominator. So that's multiplying. Here's dividing. So again, you look at just the coefficients. Divide those. Then divide the powers with the same base. Okay, so that's going to be x to the negative 4, y to the 13. So when you're dividing powers with the same base, you subtract the exponents. So I do end up getting a negative. Okay. I circle that, that's the only thing that moves. This negative 8 is a number, an integer. It's not an exponent. It stays there. The y to the 13 stays there. But x to the 4th is now in the denominator. Okay. Now, if you could have thought about, when I said imagine, like how many variables you have. If you imagined 5 x's in the numerator and 9 in the denominator, you would know there's more in the denominator. So you could go 9 minus 5, but keep it in the denominator. Okay? So if you can do that, go for it. Okay, and then last one, kind of did a similar one yesterday. We didn't have negative exponents. Similar one where it was a division inside brackets. Okay, so think of order of operations. It's brackets first. Inside there, we can simplify that using our division clause. Now, saying that, you could square everything, because there's no adding or subtracting. So you could square everything in here and then divide. It actually wouldn't make a difference. It would just take longer. But let's follow the order of operations so that we have inside of our brackets, 18 divided by 6 is 3. X to the 7 divided by x to the 4 is x cubed. And then y to the 10 divided by y to the 18 is y to the negative 8. So we use those laws to simplify inside the brackets. And then we square everything. I'm not going to deal with the negative exponent yet. I'm going to get rid of all my brackets. So now I square. So that's 3 squared, x to the 6, y to the negative 16. Okay, and then that's your negative factor, negative exponent factor. So 3 squared is 9, x to the 6 over y to the 16. Okay. Now, if you have here realized, as I said before in the division, you think about 10 y's over 18 y's, and you know you have 8 more in the denominator. You could go straight to this, 3x cubed over y to the, y to the 8, and then you could square that, and that would get you here, okay? So there are a couple of alternative orders of how you could simplify this, but this is the one that's consistent all the way through.